Okay, hello everybody. So to the second part of this lesson about Mathematica. Okay, parallel computation. This is something you surely are interested in. So the first thing is telling Mathematica how many kernels you would like to use. And this is done by launch kernels. Typically you have either 4 or 8, or you have hyperthreading or whatever. And you tell Mathematica to launch all the kernels. And it's very, very simple. It was more complicated at the beginning, but now it's very simple. It just, for example, define a function, as I told you last day, and then, for example, parallel table or parallel do, things like this. Some versions ago, probably the version 8 also, you needed to tell Mathematica the kernels to have some. And for example, if you define this function, you need to tell Mathematica to share it to all the kernels. But now it's already implied in the parallel table and parallel do. So you don't even need to tell Mathematica. And you directly do this list, L is equal to this table, from I from 1 to 10, and you store this pair of numbers. So I and function of I. And then if you print L, you have this list. It can also do parallel sum, parallel product, and things like this. You can check. There are more things. Something which is important. I mean, I think in general you should try to avoid concurrent computation. I mean, things that depend on other kernels and have to communicate among them and so on. But if you need to do it, you need to know this command, critical section. Critical section is supposed to block this variable in brackets. It blocks the variable from being overwritten by other kernels, does something, and then releases the variable. So for example, if the parallel do or parallel table is running along I, you block it, do something with it, and then release it for the other kernels to, because this parallel loop, what it's doing is just dividing the loop into several. I mean, from I from 1 to 2 is for one kernel, 3 to 4, and so on. So it needs to be blocked. Typical error you can do is, for example, I mean, imagine you define a list, an empty list, like this, then some numbers. You launch the kernels, do the parallel do. At some point, do this critical section, do something with the numbers, and then you try to put the result of this computation into the list. I mean, adding things to a list is typically done in this way. So L is equal to L, where this thing has been appended at the end. So this is very, I don't know if I told you last session, but this is very typical. This is of typical use. So in a given list which you have predefined, you append to this list in the rear part some numbers. And the error here is, I mean, the parallel do knows about A, B, and 10, but it doesn't know about L. Don't ask me why. I mean, it knows about something and not the other thing, but it's like this. And since it's not shared by the kernels, it does nothing. It doesn't append anything to L. Okay? The way to solve this is to set L as a shared variable. Set shared variable. If I do the same with set shared variable, now the kernels know about L, so it will be able to append to the list this number you are computing. But they will be, I mean, all kernels will be overwriting L at the same time, because this computation is very fast, so they at the same time write the information on L. So L is only appended one of the numbers. This is because you haven't done this critical section thing. Okay. So now the correct way to do this is share the variables, set shared variable, and do this critical section. Here you can in general, I think the log variable, you can do whatever, it will log all the kernels and allow you to do that and append. Okay. And now you print, and it's the full list from 1 to 10. Okay. Now a typical real example. Okay. Some things that are interesting. This command off, it turns off all the error. So when Mathematica finds an error, it tells you. This way, you switch off all the error printing. So, I mean, you know there's going to be some error because, you know, for example, it lacks precision up to a given amount, whatever. You already know, and it's okay like this, and you start Mathematica in the computation, and you don't want to hear about this error. So you write off, and it doesn't print it anymore. Something also very useful is timing. Inside of timing, you put whatever computation, and it tells you the real time it's using for the computation. Okay, and here is just I find some lists, I find some matrices. I launched 4 kernels. This is because it was a former version, but I need to set shared variable this list. Okay, and then parallel table. Do many things. Blah, blah, blah. And for example, here you have a table inside of a parallel table. This table is only working on a given kernel, so each kernel is going to have its own table. Do a lot of things, blah, blah, blah.
What about where you create parallelize it inside the table?
Inside it?
The table? No. Like you said that everything is making each
There was a parallel table.
There's a parallel table here, which includes all the computation, and this distributes the loop so the indices of the loop distributed into kernels. And in each kernel, everything which is done afterwards is done separately, including, for example, a table. I don't know what happens if you put another parallel table. I wouldn't try. And then, as before, you do a critical section with a false variable, then append. In general, I wouldn't do that. I mean, if you need to do, if the result of the computation is a list of numbers, you just do L equal parallel table, and inside of the parallel table, you just print the numbers, and they are stored in L. So typically, you don't need to do this concurrency checking and all that things. After that, for example, you export this list to a, as I showed you in the previous lesson. Okay. Any question about parallel computing? Anything you want to know?
Do you know it's really taking the fraction of time, it's really working? Yes?
And it's 4 times faster.
It's also work for graphics or just for operation computation or something?
Typically for computation, but I don't think they have the graphics implemented in the parallel. But I would recommend that if you have something heavy to do with graphics, you first do a parallel table with all the points and then represent it. But there's no parallel block.
About the licenses, how do you, so each of the kernel runs in one of the core of one computer, or for instance, can you?
The only thing I know about that is that in Salmonia, for example, there's a given number of licenses which are by the campus. But I mean, the only thing which is restricted is the amount of notebooks which are open. Once you open a notebook, you can put 100 kernels. Because there's only one master kernel. And there's a one kernel for each launch kernels. But there's a master kernel which is doing the critical section control, obtaining the information and printing at the end. All these things is a master kernel. And I think it's restriction per master kernel.
It must be in the same computer. If not, you cannot access the host of other computers. It must be.
No, it has to be the same computer. It is on a single computer. But so far, I have not charging you for having more cores in the computer. That's the next version. That's extra.
Okay, some useful commands for simplification. So you basically need to remember reduce and full simplify. Reduce is going to try to simplify and find an answer for whatever algebraic condition you give Mathematica. For example, I want x squared minus a to be higher than 0 and this thing to be smaller than 1. And then Mathematica is going to tell you y has to be real and all these brackets, which is either this or that. And inside these things there is and. Okay? If you tell Mathematica reduce these things, comma x, it will try to give you, so center its information on x. What is the condition that x has to fulfill and so on. So you see this line, this is the result of reduce. If you try to full simplify, you're going to try to simplify all these expressions. And to full simplify uses everything that Mathematica is able to do, and also reduce. And if you add information on assumptions, for example, y belongs to the reals, then it becomes simplified because one of the conditions is already fulfilled. And here the example is very simple, but in general, this y belonging to reals and things like that is very useful. And this assumption is exactly the same as this one. Element y reals. Here you can put element brackets x, y, a, comma reals. Okay, there's also simplified, but typically simplified doesn't do things like simplifying this, so sines, cosines, things like this, or exponentials. But full simplify is using all the probabilities. Okay. There's also complex expand if you're working with complex numbers. So you expand this, so it will give you that. And another example of reduce is, for example, this condition. It's going to give you the answer in terms of a parameter, which is an integer. The real part of x has to be blah blah blah, and the imaginary part less than that. If you full simplify this expression with the condition that x is real, then it's going to remove this real of x. You see? So here everything seems very simple, but when you have something which is huge and a monster, if you are able to put out things like this, or for example, a square root of something square that you know it's real, it's going to remove a lot of square roots. If you put that you already know that the variable is real, for example. Something a bit more advanced that I don't use, but it exists. Ah no, sorry. No, yeah. You can tell you can give rules in general, and it's done like this. For example, I define two rules. I substitute log x times y, and you remember this underscores is a definition of a function by a sum of logarithms. And I also should give the rule that x to the power k is k log x. Okay? If you remember this symbol is something like such that. So logarithm of all these things such that these rules applies these rules once. Okay? So it's going to give you, since it's a square root, it will do one half of the logarithm. It's going to stop there. If you want to do repeatedly such that until it doesn't find any more simplification, you do it with a double slash dot. Okay? And it's going to simplify completely according to these rules. I mean, typically you can also do full simplify, because this is something simple, right? But there are some rules which are like substitute anything you find which is like something else, and then blah, 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 something very complex. I think this can be useful. Another difference between, for example, solve. I mean, you have a simple equation. You want to solve x. Solve is going to give you these two solutions. But something more. I mean, the full answer is reduce. It's given by reduce, which tells you if a is 0, then the answer is this one. And if it's not 0, then that is the answer. So the full solution is typically better obtained with reduce. There are also some things which I also will use, which is, for example, solve always, which means find the condition for x such that this holds always. There's also eliminate, which is that you have this two equations, this and that, and you want to eliminate variable set. Then it gives you this equation. Something more complicated, even. I mean, if you have a theorem that you want to demonstrate, something like this, you can write down this condition. There is x such that this equation is fulfilled. Then you do resolve, and it tells you it's true. There's also for all, so the same thing that there is an x that fulfills this one. This condition tells you for all x, this is greater than 0. Resolve condition, then it gives you all the things that have to be fulfilled in order for this thing to be always higher than 0 for any x. And if you do reduce over this thing, it becomes simplified. I imagine that with full simplified also.
This condition for all is similar to reduce. Is similar to reduce. And you could just say reduce ax to the square plus bx plus c less than 0. Isn't that?
Yeah, but in this case, yes. But in general,
it could be more complex.
Yeah, for example, I saw an example in the help, and it was just writing the definition of a limit in the mathematical sense for every increment for all something exists. You can write this thing with for all and exist, but with reduce will not be the whole. So
it's more general.
I don't know, I think this is more for mathematicians. Just that you know that, I mean, and the function reduce is amazingly complex. I mean, if you look at the help, there are millions of examples of very complicated things that you can do. Questions? Okay. Here I'm going to do a function header. So this file is a .m file, so it's like a package. And here, for example, I define just a function. This function, I store it somewhere in the computer and I have it for the future. And every time I need to do this function, in any other notebook, I call it and I use it. So it's an independent file which has this function. Okay? And the way to do a definition of a function like this is more or less like always. So number of the function, the variable with an underscore, double dot, equal, and then I put a parenthesis, a bracket. Then I define things, I do some eigenvalues, some predictors, some table, and here I print the result of all this computation. I mean, the input is a density matrix in this case, and the output is some number coming from the density matrix. Okay? This cell needs to be in cell properties, initialization cell. This means that once this file is called by Mathematica, it will be automatically executed, not just open. It will be open and executed and kept in the memory. You will see two examples where this has to be done. One is in the external definition of function, and another one is when you want to call a program from the command line. Okay, so imagine I save this thing with the cell properties initialization cell. And then I want to call this function. I do that. What? Oh. And I call it the function. Okay? If you remember, the function was called discord2. I define a submatrix like that. That's it. If I call the function and it doesn't have the property of initialization cell, this function is not loaded into the memory when I call it. Okay, it's neat.
It does complain, and you understand in the error. It doesn't complain.
It doesn't load this function into the memory.
It doesn't tell you that.
And you will notice because this will be blue instead of black. Same thing, if instead of a function only I write a program, I name it program.m. I do cell properties check initialization cell, save the program, and then from the command line I can do math, name of the program. I mean, this is very visual, no? So the program is put into math, and then the output written like this, for example. And this is Linux, meaning that the command line doesn't have to wait for the program to finish, as you know. I will show you. For example, I do this program.
The syntaxes of the notebook and of the program are the same.
Yes.
So you change this is the extension, and these things about the initialization cell that you explained that are able to have it running as a. I mean, I can run also a notebook if I put the initialization option, you say, and it just changes the extension.
I don't know. What I normally do is, I mean, you are building the program, it's in all parts, and you know everything is done and working. You save it as a .m with an initialization cell. Maybe it works. Can be. So yeah, for example, I have a program. I have some functions, numbers, functions. I do a table. For example, this program is solving a set of differential equations. And here it's, I mean, when you save it as a .m, everything is more compact, it's not so nice, and so on. You don't need to, I mean, the program is supposed to be working, and that's it. So this is written like a code, more or less. I mean, and this is done once you save it in .m, it directly plots it, writes it in this way, more or less. But here, what I do is, I say equations 1 is a table of differential equations with derivative with respect to t equal to whatever. More equations, initial values, which is another table, more initial values, something important. I mean, these are, when you have, I don't know, a system of, I don't know, 200 particles, you write once the equation with label I and j, for example, and then you make a table which you are not able to write manually. Okay. Imagine you cannot write the 200 differential equations for a couple of seconds by hand. So you do a table. And then in order to plug this into ND solve, which is the one doing the work, you would do total equations is join all these equations, all the initial conditions, and then flatten. Because otherwise it's going to do equation 1 with a bracket, comma, equations 2 with bracket, and so on, and then final brackets. And then, but the command, the syntax for ND solve is one bracket, a row of things, and then finishing brackets. So you need to remove the inner brackets. This is done by flatten. Flatten. Let's flatten. Is 1, 2, and so on. And these are for different levels of removing these brackets. This I don't control it too much, but if you put flatten without this, it's going to remove all the brackets except for the ones in the beginning and end, which is what you need in this case. So at the end here, it would be equations. You can also give methods how you want to solve the differential equations numerically, and so on. Then first, as I told you in lessons before, and then something which is very useful is, okay, once Mathematica has a solution in the memory, how do I dump it into some file? Because, I mean, I don't know if you remember, but the solution to ND solve is an interpolating function. This means it gives a lot of numbers, for example, the time evolution at different time steps, and it gives you an interpolating function of these points. So it's a function which is able to interpolate any other time from the time steps that you have. So intermediate times also. And this is not something, I mean, you could ask Mathematica to do here, I mean, to evaluate this solution at many points and then export the points. But if you want to export the full interpolating function, you just want to dump the full memory of Mathematica. And this is done by dump save. Dump save is going to write a binary file, .mx, for example, with the solution, and for example, the number of particles I use. Okay. And how do you import it? You get, and that's it. You remember in this dump there is solution and the number of particles. So number of particles in black, so Mathematica knows about it. Solution 2.
But you didn't tell what was inside the file.
So not necessary. It's the full memory of solution and because you told Mathematica dump save these two things. So all the memory which is in the RAM by Mathematica regarding known and solved is dumped. Precisely, I mean, these functions, they are unknown because you didn't export them. All these functions were defined, but they weren't dumped. Okay. So you have to define them again, and you can export them. I don't know, I was looking, but I didn't find, there should be a command to dump save everything which is in the memory. I don't know how to do that. And then you use it. Okay? Yeah. If you want to put it in action. passing if an output, this is what it's going to be written. This is the output. So it's going line by line, introducing all the definitions, blah blah blah. Now it's in line 30, which is the computation of all the trajectory and so on. And when it finishes, it will jump save. We will have seen in the document. Let's wait.
Mi sta correndo una portatile?
Y no te dicen que está bien, que está muy cuando...
No, but you don't know it's
No, ya, pero es que no te lo dice matemáticas. Tú sabes que la CPU está ocupada, no te dice matemáticas.
you can put a counter in the loop. Write something every time the loop labels at all. Okay. So you see here, this thing is the result of, this is 75 seconds. You remember there was a timing command on all the loop, and then it tells you 75 seconds, and now you have produced this file. And you can check. Plots. Okay, if you want to import many files from the same directory, you just set the directory with this command, and then when you call import, you just have to give the name of the file in that folder. Okay. Here I am importing 3 lists. 2 of them are disarranged, so I want to sort them. Mathematica does this automatically. And then I'm going to do a plot, so 3 plots, and I'm going to join them in one plot. Okay? These plots are list log plots. So list because it's coming from data. It's log, so I want the axis to be logarithmic in both coordinates. And then what I do, I think I told you already that you can put twice the same list, so it's going to plot it joined and not joined. Okay, plot range all, so that everything is shown. And then here plot style. I have to define a plot style for every list that I'm putting into the plot, of course. And the first one, which is the joined one, is going to be with thickness thick, which I have defined before. With thickness, and it's going to be black. The second one, which is not joined, so it's point, going to have point size with this size, and it's going to be black. And the result is that line. I mean, you cannot see, but it has points and also the line. Okay, and this I call Y1, for example. You can also do so. If you want a frame, so normally Mathematica only plots these 2 axes. If you want to put a frame, you say frame true, like this. Then the frame ticks. You can put whatever you like in the frame axis. So, for example, so frame ticks 0.18, 0.182, and so on. These are these ones. Then none, I think it means here. And here I don't remember exactly the syntax, but if you see there, okay, I remember. So you have 2 pairs, so none and all these things, meaning this and this, and then the Y, the 2. This is here and none. So automatic, so it does whatever it likes, and none. Okay. If instead of automatic I would put 0.02 and only 0.3 or whatever, it will be only 2 numbers. You have to give core lists. The ones that you want here, the ones that you want here, in brackets, comma, and then another brackets for the pair here and here. Okay. Like matrix.
The type of the font, I mean, the font here that you have used is not the default, right?
I mean, there are several ways to do these things. I mean, if you see, I'm going to do 3 plots and then join them with show y1 or 2 or 3, and then I can give here further options. For example, label style, font size, 26. You can also say, tell font, I don't know, Arial, things like that. You can also do that by putting frame label, this, which you already saw, and then selecting these things. For example, in order to put this red, I select here. I go to format, text color, and I say red.
Okay.
Another way is the label style, font size. There are 2 ways: doing it by hand or with a command.
And the font you have used different than the default, right? Because this is like Times.
No, it's automatic, I think. I didn't tell Mathematica anything. Maybe it depends on the operating system or the version. Yeah. Okay, so all these plots have more or less the same options, so the same thickness, same point size, only varying black, red, orange. And then I put them into show command. I do plot range all, specify the frame labels, the size of the labels, frame true. This one is also very interesting, aspect ratio, so the proportion between vertical and longitudinal, and then the total size of the picture, image size. In this case is 1000.
Something with the size definitions that you give, can you scroll a bit down? I don't understand. No, in the other direction. Sorry. Yeah. A bit further. Where you have the definitions. A point is 0.01, and the size is thousands, but that doesn't relate at all to each other. So how are these sizes defined? You just try. Because the size is not 10,000 or 100,000 times the point size.
No. I don't know. I mean, you're worried about
just resolution. So you just by experience, you find out what numbers you have to put there.
Exactly.
Alright.
I don't know, if you're curious.
What? Okay.
It says so, but
Fractions. Okay. It's a total width of stuff. Okay.
but it's not.
And the size would be in pixels.
It should be 100,000. I mean, there should be the width of this plot should be 100,000 at this point.
No, I even had the same units, but now you show that the point size is in relation to the size of the plot.
Yeah, but I don't believe it. I mean, if the image size is 1,000.
But then it says you have,
you have
10
100.
as compared to that, the point size is 10.
Okay. So 100 of these points. Another list, and then I want to do a density plot. List, density plot, L, the list. Interpolation order. Interpolation order is trying to fit a function in between points, okay? With polynomials of order 6, so that the function is more smooth. Then you choose the color function. For example, here I have sunset colors, which is really nice. You can choose also, I don't know, like 30 or 40 functions like this. This one is nicer, but sometimes it's better to have other functions. Okay, now I want to plot a legend, which is this thing. This is done with plot legends, which includes all these brackets. Legend marker size 300, supposed to be the size of this, with this label style, which has 36 for a font size. Then, as before, frame labels, so alpha x with 36 of font size, total image size 400, and then you choose. You see, I mean, if you put fractions like this, it's going to print it nicely, like 1/4, 1/8, and so on. No, only the ones you like. And here I've written this in another way, and it works exactly the same, so I don't understand. Okay. It seems that this one is easy. So this would be like okay. And there I say none, none, so none, 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 none. Then the ticks for here, ticks for there.
And the quality of the figure, if you save the figure like a EPS, sometimes it's not good.
The EPS doesn't work with Mathematica.
Or PDF, and then you convert to, or PDF, maybe PDF.
PNG. PNG.
But I can say directly as a, save graphic as, and I can save a PDF, EPS, I can save it directly.
Yeah, but it doesn't work well.
It doesn't work well, yes. So this is my question. I found a kind of receipt in web page, and if you put after the plot this sentence, then it works.
Which sentence?
Well, I have a
sentence.
Oh, okay.
It's a long story. I don't know the meaning, but I know that it didn't work. So maybe.
You mean like saying? Saying export
PDF.
Yeah.
Like this.
And it's fine. When you look at the figure, it's fine. Okay. Okay, maybe the wrong way is just to save directly the figure as I.
And then the right way?
It's directly to save, like that. I mean, you click on the figure and then you save.
And you save?
Maybe this is not the way to do that.
And instead of clicking here?
Instead of exporting.
I use export to export videos and
like that, but with PDF.
yes, I put the root, the name on PDF, the element,
And it works.
Well, we can try.
Good one. Okay, so we'll learn something.
Bueno, uno sobre el 4, uno sobre el 8, cada uno.
Las versiones.
Hasta que me sido un poco.
I always do it with PNG.
Solo frazioni, se non potrebbe essere una limitazione di soluzione.
If you want more resolution, give it a bigger image size. You will have more resolution. Because this depends on what you're interested in. Okay. Okay, another example. So this is very similar to the example before. Here we have put aspect ratio 1.2, so it's taller. And here we learn for example, this frame style thick. If you want the lines to be thicker than normal. And for example, this is useful when you're trying to do inserts. You do an insert, it has to be with bigger numbers, with thicker lines, and all these things. And you can manipulate this with thick in the frame style. I think you can also give it thickness with a number, and you choose exactly what is the thickness you want to give.
Do you can put inserts in Mathematica or
you can do it, but I don't know how. Personally, I don't know, but you can put also signs on top of a graphic. So with typical thing with blue line is something, red line is something, with a square inside. With shadow, without shadow, position, and so on. But here, what I wanted to show is, apart from this thing of thickness, is the command dashing. Dashing 0 means there is no dashing. Dashing 0.02 would be this one. Dashing 0.04 would be the red one, so more separated. Okay. You can do also this kind of plots. Yeah, by the way, you can define, you can define functions of anything. So you can define the function of style, which is this triplet of commands. So thick, red, and with a given dashing. Okay. And this reduces the size of the command. Okay. And then I plot these functions with different width, and each of them I plot them with style with dashing 0, dashing 0.01, 0.03. And I can also tell Mathematica that it needs to fill. And the style of filling is bottom, in this case. Filling style automatic, if I say here, for example, orange or whatever, it will fill it with that. Okay. The filling function is rather nice. You can do very complicated things with it. For example, in this case, I put two signs which have a slightly different frequency, and then I want to fill from 1 to 2. It does this thing. For example, if I would like filling from 1 to, I don't know, a given value, I tell, for example, from 1 to 0.5, and then it would fill all this thing, and so on. And you can do many things with that, with curves that you define here. If you are interested, you just have a look at this function. It can also do this kind of plots. So this one is a string plot. This one is a string plot, so string list, string density plot. And this one is a vector plot. You can see it's the same data for all three. But here the length of the arrows is proportional to what would be the density here. and here the rows are all of them are equal.
String does not account for the velocity, does not tell you, does tell the direction of the velocity but not the strength. And this point tells you the strength of the velocity at this point. Modulus is the direction.
The direction and modulus.
Yeah.
Here it's only the...
Here it's only the direction.
You can also do contour plots in 3D with very complicated shapes and so on. You can also do region plots in 3 dimensions, for example, x times y times z less than 1, and it will plot this thing. By the way, you can turn, you see this kind of cursor, this is for doing that. If you put the cursor here, it changes to that. And depending on the number of your kernel and the version of your driver, it will crash a little bit. You can also do 3D histograms like this. There's something which is nice too, discrete plot. You give it a continuous function with a given range, and it will do a discrete plot at integer numbers. If you tell discrete plot 3D to this command here, extend size full, it will plot it like this. I think this is typically useful for representing density matrices coming from experiments and things like that. And there are many more things that you can do with the plots. For example, things like that, with bubbles, with many things. And the representation of complicated networks too. And plots with a, you don't see it very well, but there's a lattice here and so on, a grid. And very complicated contour plots too. With here, for example, I think it's all in order to tell it how it should plot the boundary size, something. There is no grid here. It is called mesh none, and things like that. And there's a color function which is this blue and orange. You can tell the color function. You can give a function to the color function, meaning, for example, do it more orange, the higher it gets. And do it more green, the closer it is to zero, things like that. So, you can manipulate the opacity, the color, kind of boundary, so lots of stuff. Okay. And by the way, there's a Poincaré thing.
Because it didn't work in this version of Mathematica, which was on the web
What is Poincaré thing? Poincaré map or?
I will tell you.
Poincaré section, yeah.
Since I don't use it, there's a package called Position Tracker. You can do things like that. Set parameters. Like this. I don't use it, I don't know what about it. Okay, that's it. You have questions? Anything you would like more to know?
Blocks.
Everything. Something I didn't touch upon. would be nice also to have another lesson about good practices. So what is faster, and when you want to optimize a program, what is better, what not to do, what to do, and all these things. But I think this is easier if you ask me in a case per case basis.
There's also something which are very bizarre. For instance, if you ask Mathematica to do the Fourier transform of a Gaussian centered at 0, it does quite fast. If you add the Fourier transform of the same Gaussian but centered at position A, it takes much longer. And the Fourier transform is basically the same as multiplied by the complex.
Yeah, I think in general you need to treat Mathematica as if it was a living being, not understanding and see what is the perfect way to fit the information.
That having an extra parameter or whatever makes them whatever evaluation. So, and that happens sometimes with some things that you tell it in a given way. And there's another thing, that the simplification of complex functions. Mathematica, if it has something like, I don't know, e to the I a plus minus to the minus I a, well, that's cosinus a divided by 2 or whatever. But it takes a while for, I mean, it's not easy to say, simplify that, and it will not simplify to cosinus.
Yeah, I think that the way is to play around with full simplified, adding the assumption of some parameters or variables are real, and complex expand.
Yeah, but there is a way to tell simplify that for you cosine is preferred than exponential or the other way around. I mean, at some point e to the IA plus e to the minus IA is completely simplified. Does not have any else simplification. Except for the fact that for humans, cosine is more understandable.
Well, you can use S to trig. S exponential to trigonometry.
You can use a function?
You can use that, yes.
Okay, and that forces go to trigonometry?
Yes, to cosine.
Okay. And that's what is an option of simplify, or?
No, it's just to take your expression and put S to trig.
Okay,
It's
evaluate that, okay, good. That's one something that.
But it's true that to manage with complex number with Mathematica sometimes is very hard to do. Unless I guess that you impose some conditions like these variables, they are always real, and then the Mathematica can treat.
And the assumption is something that is tricky. For instance, the square root of a to the square, Mathematica is not going to simplify as a, because a is potentially a complex number, so the square root of the square might not be the same number. It might be the same number, branch it. Because the square root is multivalent. I understand that could be in a mathematical world, but not in physics. So you have a square root of a to the square, typically is a. But it does not simplify that. If you assume a positive, it will do. But if not, no.
Because it's not.
Because it's not, and it could be plus minus a.
It's more
it's
a. It's not a.
It's more root of a. Okay, but typically you would simplify for a. No, it's not more root of a, in fact, it's a with a same.
Okay.
There are also functions to expand things in Mathematica or something like that, and also the factor, the good common factors.
The other thing is that what the one mathematical thing was is that something that Maple did long time ago. Imagine that you have, I don't know, something plus minus or plus logarithm of the same something plus the square root of the same thing and whatever. So Maple immediately defined automatically this symbol is going to be all this thing. And the answer to be this thing plus the logarithm of this thing plus whatever. That's it. So a simple answer. Mathematica will write the whole thing plus the logarithm of the whole thing. You will not recognize, I mean, if you tell, you will do, but it will not recognize that too. Well, it is easier for you to visualize the result if you collect all that thing, which is a big package, in a new variable. And Maple, since the very early versions, already did that. When it finds some common factors which appears repeatedly in the solution, it will collect that with a given symbol. I don't know if in Mathematica, now that there is, I mean, so many versions, is any way to force Mathematica to look for expressions which are repeated. So if every time you say x to the square plus 2, 20 times, just in the solution just say, oh, this u and then this u plus. Do you think there's any command that tells look for patterns or whatever within an expression?
I don't know. I mean, mathematics is huge. There are so many things I don't know. I mean, what I've been telling is, I think it's the basics.
You don't understand that.
Only that.
Since you asked the question.
Okay. They are in the floating server, or the disk server, Illetes or Dolsa, in Fernando, public. En el disco flotante, el disco que compartimos todos, en mi usuario Fernando, public.